Moving right along into chapter 5, polar coordinates. This will probably be a section that, not that the trig, it may have been new to you, but this will probably be new to almost everybody. Polar coordinates are interesting. They're definitely used. You'll see them a lot more if you're in engineering, physics, and courses like that. So let's see what they're all about. All right, so you're used to the rectangular coordinates where you have an x-axis and you have a y-axis. The polar coordinate system, you have a polar axis. And typically it looks like this, okay? But it's hard to draw because it's a little busy, right, with stuff. But you do have a polar axis, and then we call, instead of the origin here, we call it the pole. And so once again, as you can see, if you start at the pole and draw a ray, and then of course, another one, you're going to get a particular angle, and that's what we're going to be looking at. So that's what this shows. It says a point P in a polar coordinate system is represented by an ordered pair, the radius, and then theta, which is my angle in radians. All right, so if r is greater than 0, then r is the distance of the point from the pole. So again, think origin. So this distance would be r. If theta is an angle formed, and theta is an angle formed by the polar axis, which is your x-axis, and a ray from the pole through the point. So all we're doing is we're moving an angle and then a distance out based off of this value of r. So it says, suppose the polar coordinates of this point look like this. So remember, when you're used to the rectangular coordinate system, you're used to x comma y. Well, now you have to get used to r comma theta. Something else to learn, right? Okay, so I know 2 is this distance here, and then I know pi over 4 based off of what we've been doing with all of this degrees to radians and all that good stuff is 45 degrees. So this is how I would actually draw this graph. Typically I draw the angle first and then just label the radius, go out 2 units along the terminal side. So this is my terminal side, and go out 2 units, and this would be my point. So again, just kind of a weird different way of thinking. If you have a negative r, that's okay. What you do is you just go the opposite. So you still, and this is why I do the angle first. You do the angle, and then if you have a negative r, then you just go the opposite side. But you still state that this is a distance. That's why the absolute value. You still state this is a distance, but you go out the number of units in the opposite direction. So if I want to plot this point -3 2 pi over 3, first thing I do is I plot the angle 2 pi over 3. And notice if I go 1, 2, 3 units, if that was a positive 3, my point would be right there. But this is negative, so I go to the other side, 1, 2, 3, and I get my point. So practice these, right? So it says point with polar coordinates are theta, so my radius, my theta, angle in radians, can also be represented by either of the following. Now this should make sense to you because of periodic properties, that we can go whatever angle and then plus 2 pi times some value, like in other words 2 pi times 2, which would be 4 pi, and so on. The polar coordinates of the pole 0 theta, where theta can be any angle. Okay, so in other words, we're going to start at the pole 0 and then go out whatever our angle is. So based off of that periodic properties, that's what we're going to do here, is we're going to say plot the point with polar coordinates 3 pi over 6. So go your angle pi over 6 and then go out a distance of 3 units, and then find other polar coordinates of this same point that based off of these restrictions. So the first one says my radius is positive, so it's just going to be 3. But now it says keep it between 2 pi and 4 pi. meaning I've gone all the way around, right? Because 2 pi is a complete circle. And so what I do is I draw the original one first, so I know what I'm looking at. And then to get my first one going all the way around, I would go all the way around and come back to that angle, pi over 6, and then go out a distance of 3. Got it? And that's what this is saying right here. So how do I know how far I went? Well, I went all the way around 2 pi and then added pi over 6. And that's what I'm doing over here is I'm getting a common denominator, and that gives me my new angle, 13 pi over 6. All right, the next one, r is less than 0. So that tells me now I'm going to change the 3 to -3. And I want to stay between 0 and 2 pi, so I'm not going all the way around. So if you think about it, draw your angle. So your angle, you go pi over 6. And then I'm going to go the opposite direction out 1, 2, 3 units. So I'm at a point, if I'm at a point over here, okay, so I'm trying to figure out, well, where is the actual point? Well, I have to notice here what I did is I took pi, because remember, if this is a straight line, that's 180 degrees, or pi, and then added, because based off of geometry, this angle and this angle, if I draw a straight line there, will be the same. So then I added pi over 6, and I get my new angle, 7 pi over 6. All right, the last one, r is greater than 0, meaning I'm still going to use 3. But now this wants a negative angle. So in other words, between -2 pi, so I'm going the other way. I'm going clockwise. And so again, I start with my original pi over 6. But then I say, well, let's go all the way around back to this point. Okay, well, what is that angle? Well, if I go pi over 6 and then I subtract -2 pi, that's going all the way around, I can actually get my angle. All right, so this, again, this is something new and different that you want to practice a little bit, how to draw these, how to recognize, not only to be able to recognize them, but the big key, this example, how do you find that angle? All right, and we will move on to the next part in the next lecture.